All right, hi scholars. Today we're going to do 3.7 sinusoidal function context and model data modeling. Honestly, today's lesson, nothing is new. We are just going to look more into like modeling that we've done before, right? So you'll be given a context, usually in word problem, and figure out how to use a sine or cosine graph, function, sinusoidal function on it. All right, quick reminder. Sinusoidal function looks like this, the wavy one, usually for the sine and cosine, and that's the basic form we use with the A being in the front, amplitude is absolute value of A. D is usually the midline, the number that's vertically shifting number at the end. B has to do with the horizontal dilation, period is 2 pi over B. And C is the shifting, phase shift, left and right. All right, we skip one. Too easy. Number 2, the sine function is the cosine function. We are looking for the constant C, which really is the horizontal shift. To do that, if you're in my class, you know always the first thing you do on your graph is what? Draw the midline. Midline saves a life, right? So there's a midline. Now we are looking for the cosine graph. Do you remember what the cosine graph, the parent cosine function looks like, right? It looks like that. So we are looking for behavior that goes from the maximum going down. So from here, where do you see the maximum that goes down? Ooh, I see right here. There is the behavior of the cosine function right here. Or you can see right here at negative half to pi going there. That means that plus C can be, if it's shifted pi over 2 to the right, C is going to be negative pi over 2. This line. If you're talking about this line over here, it's going to be positive pi over 2. Either way, it's going to be pi over 2. So where is that? C. Okay? There you go. Let's read it. A yo-yo that is attached to 30-inch long string is rotated at a constant rate. The figure provides a representation of yo-yo in xy plane with the direction of rotation indicated. At t is equal to 0, the yo-yo is begin to rotate. The yo-yo is at start position in the figure. At t is equal to 5, the yo-yo has completed 20 rotation, and yo-yo is in the same position as t is equal to 0. So which one should I use? That's pretty much what it is. Do you guys know yo-yo? Yeah, it's a fun one, isn't it? All right, so imagine that's like there's a yo-yo at the end of this, okay? So you're at 0, 0. At t is equal to 0, your yo-yo is facing bottom right here. And it goes around, right? There's a yo-yo at the end of it. It goes around, round, and it goes 5 times. Whew, I'm too dizzy. At t is equal to 5, it completed 20 rotation. So go 20 times after 5 seconds, and it ends over there again. Does it kind of make sense? Hopefully. All right, so let's find the period, shall we? 20 rotation in 5 seconds. Then how long does it take to do the 1 rotation? Wouldn't that be 5 over 20, which is 1 over 4. So it takes 1 over 4 seconds to do 1. So it's like this. 1 over 4, 2 over 4, 3 over 4 seconds, 4 over 4 seconds. So it makes 4 circles in 1 second. That's how you can think about it. Does that kind of make sense? Okay, so that's your period. All right, why do we need it? If you look at it, all of the choices have the sine function with the amplitude being 30. So I'm not even going to worry about it. Only difference here is the value of b, which has to do with the period. What's the formula for period? 2 pi over b. Remember that? That's a period. And we found that period to be 1/4. So really, we are kind of working a little backward to find the value of b over here. Cross multiply, 8 pi is b. So the number that's multiplied to the t has to be 8 pi. Letter D. Yeah? All right. Excuse me. A clock is mounted to the wall, and the point P is located at the tip of the minute hand of the clock. The function h represents the height p from the ground with the sine function. Okay, so when you start at t is equal to 0, it has height of 70. And when it's 30 minutes, it has the distance from the End of the minute clock to the floor is going to be 52. What are we looking for? We are looking for A and D value. Remember, D is the midline and A is the amplitude. So really, that's what we are looking for. All right, folks. So clock is right here at t is equal to 0. Wouldn't that face up there? Right? T is equal to 0 and the whole thing is 70. Right? When it's 30 minutes, you know your clock, hopefully you do, it's going to face downward. And then what's the distance from here to here? The end of the minute to the floor is 52. So really, that 70 is going to be the maximum value of the sine function, and 52 is going to be the minimum value of the sine function. So I don't really care about t. So if you were to graph it, it's highest at 70, lowest at 52. That's what that means. Would you be able to find the amplitude? Yeah. Would you be able to find the midline? I think so. All right, so midline is the line that goes in between 70 and 52. We can use our hand, but whatever, we have a calculator, so let's use that. So what is 70 plus 52 divided by 2? We're looking for the average of that. So midline is 61. D is 61. Amplitude is a distance from the midline to the maximum, midline to the minimum. 61 to 70 is 9. What is 9 plus 61? What are we doing? I guess we're not adding. So A is 9 and D is 61. There we go. So we don't really need to know the period or anything like that because I'm not interested in B. I can find out what B is probably, but problem didn't ask. Bye-bye. All right, number 5. This one's a little confusing. But if you ever don't understand what's happening, my go-to is graph. Like when I graph it, it makes so much sense to look for what I'm looking for. Let's look at the average temperature in Fahrenheit for sinusoidal function for M is 1 to 12 months. Based on this model, what are we looking for? We're looking for maximum. And then the M value, the input value, when it's a maximum, minimum. All right, so I'm just going to graph it. Are you good with that? All right. Midline is at 61. 61.2, excuse me, the D, right? So I'm just going to draw that. We kind of need to know a little bit about the period. So let's go. That's the value of B. Period is 2 pi over B. That must be equal to pi over 6. Cross multiply. 12 pi is B pi. Oh, pi day is coming, isn't it? All right, B is 12. Sorry, I got a little distracted. What am I doing? Oh, my word. All right, scratch that. I was confusing you. Sorry. I wasn't thinking. All right. B value is pi over 2. So 2 pi over B is going to give you period. 2 pi multiplied by reciprocal. You learn in middle school. Keep, flip, whatever stuff. I got 12. 12 is period. That is your period. You good? All right. Now what? The maximum value, well, that's a midline. Amplitude is 25.7. So the maximum value is going to be, what's 61.2 plus 25.7? 86.9. And then the minimum value is going to be the midline minus that. 35.5. So it's going to go like this, right? But where does it start? That's pretty important, folks. Do you see that means 4 shifted to the right? So I'm going to start at M value of 4. Yeah. And I'm going to resemble the regular sine function at 4. Once again, why did I start at 4? Because that's shifted 4 to the right. So I'm going to start at 4. 1 cycle. We said period is 12. What's 4 plus 12? 16. So the same thing happens every 12th time. What's in between those two? 10. Are you with me? I'm also going to go to the left as well. Why not? That's horrible, but you get the point. Minus 6 is negative 12, negative 2, minus 6 is negative 8. Am I doing my math right? I hope so. All right, so that's what my graph looks like right there. By the way, in between those two is going to be what? 7? Okay. Maximum average month temperature is 61.2 degrees. No, maximum is 86.9. Bye-bye. The maximum average happens at m is equal to 1. Where is m equal to 1? Probably right here in between 4 and negative 2. Does 35.5 looks like maximum to you? Absolutely not. It gives you the minimum. So that's not true. The minimum average is going to be 61.2 minus the 25.7, which was 30. That is correct. The minimum happens at m is equal to 7. m is equal to 7, it's the maximum. All right, so what's the key for this? Draw the graph. Draw the graph. Yay. All right, I'm going to stop the video, and then the next video is going to require you to do the calculator. So get your graphing calculator out, and let's finish it up.